Multiplication with arbitrary precision numbers. Multiplication techniques I used here may have different hardware in today's computers. In the today's computers, here I try to explain my way of multiplication logic. It may be different in actual computer hardware. In binary arithmetic, if multiplier digit is 1, the multiplicand is added to the result, then the result is shifted to the left. If multiplier digit is 0, result is shifted to the left, there's no addition. We move to the next digit of multiplier. About two steps are repeated continuously until multiplier digits end. This means the operation is over. Example, assume that multiplicand is 12 in binary form and multiplier is 5 in the above loop. Let's show how this works. Okay, here we have the 12 multiplicand and the multiplier. The multiplier, since the least digit is 1, we add the multiplicand to the result. Multiplier is 1, so we add multiplicand to the result. Since there is 0 as the next digit, so we shift the multiplicand or result one digit to the left. Then we come to the multiplier digit binary 1. Then we add this content to the result, and then we get this data. When you add the multiplicand is added to the result, and then the result becomes this value, which is actually 3C in hexadecimal form, which is 60 in 10 form. In this example, I tried to show how multiplicand could be handled in computer hardware. Note, here the last digit of the multiplier didn't change the result, which is 0, so it's not shown in the steps. Now we assume that we have decimal digits. Here we have 1, 2, 3, 4 as the multiplicand and multiplier as 1, 2, 3. The result is multiplier 3 means we are going to add multiplicand 3 times to the result, which is 3 times 1, 2, 3, 4. Then we shift the multiplicand 1 digit to the left, and then comes the multiplier 2. Multiplier 2 means we are going to multiply this content, shifted content 2 times, and we are going to add this to the result. And then comes 1, which is, then we shift the multiplicand 1 more digit to the left, then comes 1, so we are going to add 1, 2, 3, 4, 0, 0 to the result, which is 15, 17, 82. Now let's get this algorithm, multiplication algorithm for the Java program. Save the length of number and number 2 as number 1 and number 2 respectively. And then while we are going to multiply with the second number, so we are going to get that I, and we are going to add 1 to the number 1 to the result n times, add this n times, where n is the current digit of the second number. Then we will shift S1 to 1 digit left, decimal digit left, and then we add the result, this data to the result. Then we get to the next number 2 digit. Number two digits, and when the number two digits are ended, the result is invariable result. This is a very simple algorithm. Example program. In the example program, we have we enter the multiplicand, and then we enter the multiplier. The result is this value, 5 times this and 3 times this, shifted by 0. And then we have a very huge number and this data, and then what we do here is multiply by 4, shift by 0, multiply by 3, shift by 0, one more digit, multiply by 2, etc. And here is the result.